All right, in this video, we are going to discuss a concept called personal probability, and then I'm going to talk about how that relates to an assessment between risk and making smart decisions. So we talk about smart decisions. Hopefully, the last thing that comes to mind is betting on sports, but I find that is the easiest way to talk about personal probability and betting in a casino. Um, or if you're someone like me who would rather drive than fly, you are risking behavior based on personal probability and not statistical probability. So basically, personal probability is when you make decisions based off of percentages that are not in your favor. Okay, so when I talk about the example of rather driving than flying, statistics show that there are less accidents in the air than there are on on the Parkway or on I-95. You're more likely to get in a car accident than you are in a plane crash. So, obviously we all cope with the way we travel differently, and we all handle our expenses differently as well. And one of the things that's become prevalent in the state of New Jersey is sports gambling. And I'd be lying if I said I'm not interested in it because it's tempting. Well, what's not tempting about it? And one thing you want to think about before you choose to bet on sports is to make sure that you're not doing anything that is jeopardizing your future and jeopardizing your financial situation. And most importantly, something that's not jeopardizing your lifestyle. When it becomes an obsession, that's when it's a problem. And when you bet with your heart and not bet with your mind, you are using personal probability. So in this video, I'm going to show you how a betting slip works and why it's really, never in your favor to bet because you're always going to lose money in the long run. But let's say we pick two of my least favorite teams, the New York Giants and the Dallas Cowboys. And this would be motivation for me to not bet on this game because I, as an Eagles fan, cannot stand either team. Okay, but let's say I had to. This is how it works. This spread is basically how many points each team is getting. It's a way to dictate how do I make this game a 50-50 bet? How do I make it the flip of a coin? So in this game, the Giants are the underdogs and the Dallas Cowboys are the favorite. All right. How do I know that? Is because that if I bet on Dallas, they have to win by at least 5.5 points, which is logically impossible in football. The way you like to think about it is they need to win by 6. Okay, that's one way to think about it. Is they need to win by 6, and then I win money. All right. So if I put $20 on Dallas and they win by 3, I actually lose. Right. If I put $20 on the New York Giants and they lose by 3, I actually win because I'm getting this plus. Think of it as I'm getting 5.5 points. Now this number here is tricky. All right. What this tells me is if I put forward $100, okay, what I can expect back in return. Okay. Or in other words, another way to think about it is how much money do I have to put forward to gain $100? So in order to win $100, I have to put forth 110. All right. So you're taking a 50-50 bet and you're risking more than what should be what's called the expected value. Okay. So, the house is always going to take a certain cut, usually 10%. So your payout is never really a 2-to-1 payout. It's never a 50% payout, meaning like if I risk 20, I'm not going to recoup 40. I'm not going to get $20 back and get $40 back. So it's actually not a good deal, right? If you want to bet just on the game itself, you can bet on what's called the money line, which again is not advisable because let's say we bet on the Giants, they're favored to lose, so the likelihood of them winning is not high, right? Now, Dallas, the likelihood of them winning is much higher, but in order to recoup $100, I have to risk 200 of my own. So it's not playing the probability, wisely. It's playing with your heart. Okay, and then the rest, this is over under. For the sake of time, I'm just going to skip forward. Long story short, don't do it. If you're going to do it, have fun with it and do it in moderation. What I want to try to look at tonight is this thing called risk. We hear risk all the time. And, what that means for probability is, how do I balance out the numbers with what I want to do? That's a simple way to think about it. What do I do when I'm given a data sheet, when I'm given percentages, and how does that affect my behavior? Well, not too long ago in the year 2014, this man over here with the Creighton logo on his face, this is Mr. Warren Buffett, one of the proudest and most successful Creighton alum, let alone people in the world. He offered all participants worldwide to fill out the March Madness bracket. And if anybody in the world got a perfect bracket, he was going to pay them $1 billion. Think about that. I don't have to put forth, now this is different than sports betting because it's free to enter. I don't have to pay any money. I just sign up, I fill out my bracket, and I have a chance, in the words of Lloyd Christmas, to win $1 billion. Who wouldn't do it, right? Face value, doesn't it seem like a risky situation for Warren Buffett, even as rich and wealthy as he is, to risk $1 billion on the chance that Joe Schmo wins a perfect bracket? It's pretty risky, right? It sounds like a pretty risky endeavor. But let's break it down from a statistical perspective and see the risk, the probability of selecting a perfect bracket, because it's a lot harder than it might look. All right. If I asked you real quick to count up all these green little check marks, okay, and when we talk about the bracket itself, just to give those of us not familiar with the March Madness tournament, which unfortunately was canceled this year and I'm still bummed about, it's a single elimination tournament for the 64 best teams in college basketball. There's both a men's bracket and a women's bracket, and it's a lot of fun to watch. And basically, to pick a perfect bracket, you have to pick 63 games correctly, okay? Now, for the sake of this exercise, all right, and we're saying it's an exercise not because it's a game. We're talking exercise in terms of the statistical, mathematical realm of the word exercise. We're going to say that each game is a toss-up, okay, which is going to leave us with a percentage and a probability that's probably a little lower than what it should be, okay? But in theory, 50% is a good number to use, right? So what's the probability if each game is a 50-50 shot? What's the probability I pick 63 games correctly? Well, there's this little rule in probability called the multiplication rule, which basically says if you have independent events, that you can multiply the probability of event 1 times the probability of event 2 times the probability of event 3, so on and so forth, and it gives you the total summed probability of all those events, right? So to figure out the probability of picking a perfect bracket, I would take 50% and multiply it by itself 63 times, or shorthand, 0.50 to the 63rd power. When you do that, you get an astronomically very minuscule number. You get 1.084 times 10 to the negative 19th, which, if you remember from your days in science class, when I have a number that's an exponent that's negative, I move that decimal place 19, think of those 19 humps to the left, and that is the decimal that returns, okay? 0.18 zeros and then a 1. Now, I want you to think about that in terms of odds or a fraction. To follow this pattern, if I had 0.1, we read that as 1 out of 10. If I had 0.01, I read that as 1 out of 100. 0.001, 1 out of 1,000. So what the heck is 0.00000000001? It is 1 out of that number there, which is 10 quintillion. And you might be thinking, well, where does quintillion come from? Here's a million, here's a billion, here's a trillion, here's I don't even know what that, a quadrillion, and here is quintillion. 1 out of 10 quintillion. All right. To put that into perspective, a number that large, 10 quintillion. Heck, think just 1 quintillion. Okay. There are roughly, give or take, 7 billion people in the world, right? 7 billion. The means to have the ability to fill out a bracket with internet access, with the device, you probably cut that number in half, right? But let's just use 7 billion for now. Let's say everybody has the ability to fill out a bracket online and submit it to Warren Buffett's challenge, right? All 7 billion people. Each one of them would have to fill out 1 million brackets. You'd have to fill out 1 million, I'd have to fill out 1 million, and everybody else would have to fill out 1 million unique brackets. The thought of doing that would take 5 lifetimes. Can't even do it, right? That would get you to a bay of 10 quintillion brackets, all right? Starting to see where Buffett is going with this, all right? Are you starting to think that it's risky? Okay, because I'm not. I'm starting to think it's not that risky. And if you really wanted to get down to brass tacks, you could come up with the expected value or the expected payout for this scenario for Warren Buffett, right? An expected value is the product of either the payout or the monetary value or the numerical value of whatever behavior you're considering, and you multiply it by the probability or the likelihood of that happening, right? So in this scenario, the payout or the experience for Buffett is, let's call it what it is. He's going to have to chalk up and dish out $1 billion, negative 1 billion, all right? Multiplied by this probability of 1 times 10 to the negative 19th, or 1 out of 10 quintillion, or 0.000001. We do the math on that, and we get negative $1 times 10 to the negative 10th power, which translates to not a penny, not a penny of a penny, not a penny of a penny of a penny. It is a mere, I don't even know what you would do. I'm thinking of Office Space, where he rounds the fraction and he creates that whole mess of a bank account, and they have to, you guys know what I'm talking about? Well, if you don't, think about it like this. He's not losing any money. He's not losing a darn thing from this, okay? He's expected to lose a fraction of a fraction of a fraction of a penny. So what did Buffett do? He risked statistically nothing for a ton of advertising, for a ton of shock value websites and news articles, and all this goodwill for Berkshire Hathaway, for Quicken Loans, for all these companies that he is tied to. He's a genius. He's a genius, and that's the reason why.